Hey everybody, it's Mr. Oaks. So today we're going to talk about some basic exponent properties. These are just a few of them. I'm going to make another video on two other ones, but I figured I'd start off with these four. There are a number of different properties that we can use when we're working with exponents. The thing to remember is that exponents just represent repeated multiplication, so that something like 3 to the fourth is 3 times 3 times 3 times 3. So the exponent tells us how many times the factor, the base, shows up. So a couple of properties we're looking at. The first one is called the product of powers property. It's basically when we have two powers with the same base multiplying each other. So the general form is x to the power of a times x to the power of b equals x to the a plus b. Basically what it says is that when we multiply two powers with the same base, we get an equivalent expression by adding the exponents together. And the best way to do that is to show you a couple of examples. I'm always going to do one where I'm going to show the long way, the expanded way, and then the other one I'm going to do using the properties so that we can do it very quickly. The first expression here is 7 to the fifth times 7 to the fourth. So they have the same base. Remember, the base is the big number that the exponent is attached to. So in this case it's 7. Well, in the first one we have 7 to the fifth. So what that means is we have 7 times 7 times 7 times 7 times 7. So you see 7 shows up 5 times. And we're multiplying that by 7 to the fourth. So that's going to mean that 7 is going to show up 4 times. 7 times 7 times 7 times 7. I am going to wind up a little bit in this area. Not a big deal. Well, we know that our base is 7, and then what we're going to say is, well, how many times does 7 show up? 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So our exponent is 9. And if we look, 5 plus 4 gives us 9. So that's another way we can get the 9. So we'll do the second one here. 9 to the sixth times 9 to the second. So what we're going to do is we're going to keep the base and we're going to add the exponents. So I have 6 plus 2. So we get 9 to the 8th. And that's it. That's all we do when we are multiplying powers with the same base. Now, sometimes we're going to have powers that have different bases. And that's where the power of products property comes into play. What's important with this is that we can combine and kind of simplify when we multiply two things with different bases, but the important thing, the very key important thing, is that they have the same exponent. If they don't have the same exponent, we really can't do much with it. Okay? So we have here a to the x, so a to the x power times b to the x power is going to give us a times b, that's all in parentheses, to the x power. So the product of a and b to the power of whatever x is. So again, I'm going to show what happens here. It's a little tough to see, but this says 4 to the third times 2 to the third. So what we have is and I'm going to put this in parentheses, 4 times 4 times 4, and we're going to multiply that by 2 times 2 times 2. What we have is we can actually pair up 4 with a 2, this 4 with this 2, and then that 4 with that 2. So what we're going to get is 4 times 2 times 4 times 2 times 4 times 2. So really what we have is 4 times 2 to the third, because it's showing up 3 times, the same exact thing. And 4 times 2 is 8. So we get that our answer is 8 to the third. Now this is obviously a little bit more complicated than the other one, but we still can do some like quick stuff. So I have here 5 to the 10th times 8 to the 10th. Well, I see that I have the same exponent, so I know that I can multiply the bases together and keep the exponent. So what I'm going to do is, in parentheses, I'm going to do 5 times 8, and my exponent is 10. 5 times 8 is 40, and I'm going to keep my exponent, so this is 40 to the 10th power. Now you're really not going to see a lot of these type of problems, but it's still very important to understand and know how to do them in case they do show up on a test or a quiz, quarterly, state exam, whatever. Homework, it's going to show up on my homework. Alright, so you got to make sure you understand these. Okay, these two, similar but different. Got to pay attention. Very easy to mix these two up. Okay. 2 more properties we're going to go over in this video. The third one is called the Power of Powers property. It's kind of a power of power property. Alright? Power of Powers, which basically says if I have a number or a variable and I put it to a power, and then I take that and I put it to a power, what I'm going to do is I'm going to multiply the 2 powers together. So I have here x to the a to the b is going to be x to the a times b. Here's my example. I have 2 to the second to the fourth. So I'm going to show you a very long way with this one. This, first I'm going to change what's in the parentheses. I'm going to say it's 2 times 2 to the fourth. Okay? Then, let me get on this side, this to the power of 4 says what I have here, this parentheses is going to show up 4 times. So I get 2 times 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 2. So again, I'm working my way into this other one. And when I look at that, I keep the base. Alright, my base is 2, so I'm going to keep that 2. And then I'm just going to count how many 2's I have. 1, 2, 3, 4, 5, 6, 7. I have 8 2's, so that's my exponent. And if I look, my 2 exponents here, 2 and 4, when I multiply them, that gives me 8. So that's how I get my exponent of 8. So I'm going to use that in this next problem. Here I have 4 to the 6th to the second power. So what I'm going to do, let me go over here again. What I'm going to do is I'm going to keep the base. The base is 4. And I'm going to multiply the exponents. I've got 6 times 2. Well, 6 times 2 gives me 12. So my exponent is 12, so I have 4 to the 12th power. Okay? You should kind of see that these really aren't that difficult if I'm paying attention. And when I do these, you'll notice I didn't change 2 to the second to 4. I expanded it. I expanded it to 2 times 2. I'm showing my repeated multiplication. That's what I'm doing. Alright? The last one we're going to do is the quotient of powers property. So that's when I have, I'm dividing powers with the same base. And what that basically says is, if I have two powers with the same base and I'm dividing them, then I'm going to keep the base and I'm going to subtract the exponents. So with this, I showed the two ways we could see division. One is where it looks like a little bit like a fraction. So x to the a power divided by x to the b power gives me x to the a minus b. I'm always starting off my subtraction with whatever the exponent is on the top. Okay? Or with the division symbol side to side, x to the a divided by x to the b, again, gives me x to the a minus b. So how does that work? So I have here 3 to the 5th divided by 3. Now, the thing to realize, when I first look at this 3, I go, well, there's no exponent on it. You have to remember, if I see a number by itself, that means there's an exponent of 1. So I'm going to put a 1 here so I remember it. And what I'm going to do is I'm going to go like this. Okay. So I'm going to have, I'll move over again like this. 3 times 3 times 3 times 3 times 3. And I'm dividing it just by 3. And what I'm going to do is, I'm going to cancel out my what I have on the right side of the division sign with what's on the left. So I'm going to see I have 1, 3 on this side. So I'm going to cross off a 3 on this side. And then my answer is just what's left over. So I have just this. Just those 4 3s. So my answer is 3 to the 4th. And if you stop and think about it, what's 5 minus 1? It's 4. That's how I get that one. Here, I might actually do this one the long way. No, I'm going to do it the short way. I look here. I've got 6 to the 8th divided by 6 to the 2nd. Same base, so I'm going to keep the base. And I'm going to subtract the exponents. Alright, let me go back on this side. 8 minus 2. So I keep my base is 6. 8 minus 2 gives me 6 as well. I could also show this one out by expanding it and having, 6 times 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 6 over 6 times 6 and cancel out the 2 6s on the bottom with 2 of the 6s on the top. And I'd still be left with 6 to the 6. Okay? I hope this is helpful. I really do. If you still have questions, remember, you can always contact me through Remind, leave a message on Google Classroom. My wife can make a ton of noise in the ice maker right now. Thanks, babe. And just make sure to contact me. Come to Extra Help. Hopefully this helps, but you need to ask questions when you're unsure of things. Hope everybody does well in this homework, and I'll see you in class. Bye.